so tonight you're going to be finishing the graph, which most of you will finish today in class, and then you're going to do the questions on the back of the lab, all right, which I'll go over with you. Remember, so I wrote this lab, so we're making a lot of adjustments, so I'm going to be explaining a lot of things. I still stand by it as a pretty good lab, but we're going to make adjustments, and so when you go home tonight, you should, if you listen to everything I say, you should have all the information that you need. Okay. Okay. Now, so today you're going to first start out by graphing the data. So first, one of the confusing things is that there are 4 points for each x variable, right? So that's a little confusing. There we go, that's better. Okay. So this is my x, and this is my y, and so as we discussed on Friday, this is going to be my independent variable, and this is going to be my dependent variable. My independent variable is the one that I manipulate, that I change. So in this experiment, which one is the independent variable, the baking soda or the vinegar? The vinegar, right? The acetic acid is the one that I change, and the reason is because the baking soda is in the tablet, and we used 1 tablet for every trial. So because of that, the thing that we changed was the milliliters of the acid. So that's going to be here on the independent variable axis. You're going to have a title, and then you're going to have units. And on your dependent variable axis, you're going to have a title, and you're going to have a unit of what you measured. So your dependent variable is what you measured. So what did we measure? Right, we measured the carbon dioxide released, and the units were in grams, so that's what we measured. Now, it's a little complicated because we did 4 trials. So for each 5 milliliters, 10 milliliters of acid, we did 4 trials. So what that means is that at 5 milliliters of acid, there are actually going to be 4 points. And I don't know what those 4 points are going to look like. I'm just telling you. There's going to be 4 points. So you're going to go over to 5 milliliters. You're going to graph the mass of the CO2. You're going to go over to 5 milliliters. You're going to graph the mass of CO2. Everybody okay? So there's going to be 4 points, vertical points. And then at 10 milliliters, there'll be 4 vertical points. Okay? Just like this. All right? Now, if you have, once you finish, you're going to want to put in your trend line. This is a scatter plot. You will not be connecting the dots, which would be very hard since there's 4 of them at each point, right? You can't connect the dots. So you're going to do a trend line. Now, a trend line is a very vague showing of what trend your data is taking. So there's lots of trends this data could be taking. For example, it could take this trend. All right, it could take this trend. Leveling off, right? Leveling off. It could take this trend. A completely flat line, right? It could take this trend. A steady increase. It could take this trend. A steady decrease. Okay, notice there's not connecting lines. I'm just putting in lines showing trends. In economics, often you'll see a graph with a scatter plot, and you'll see a trend line like this. Just a little itty-bitty line showing this is what I think the trend is. All right? So all your trend line is doing is it's showing a trend that you believe that you see in the data. And the idea of the trend is that it continues onward. So therefore, if I continue to increase my x-axis, then you can see what I expect to happen with my y. If I continue to increase my x-axis, you can see that my y will continue to increase. If I continue to increase my x-axis, eventually my y will reach 0. Everybody with me? So it's going to continue. That's what your trend line is telling you, that you're not expecting it to change. So if I give you a trend line that looks like this, and I say, what's going to happen if I increase my x? The answer is, oh, it's going to decrease. No, your trend line is showing it's going to stay the same. That's what your trend line is showing. Everybody with me? Your trend line is showing what is going to happen in the future. Okay? Now, so you're going to want to put your trend line in. Two things in graphs when you're hand graphing and when you're doing it on computer too. If it is an anomaly, which is a big word for an outlier, like you guys say outlier, that's something that you learned probably in middle school. But now, as you're getting into statistics, we start saying anomaly, which means like not relevant to the rest of the data. We put a triangle around it. You are welcome to do that. You do not have to. That's not required. But I'm like trying to teach you a little more, right? Okay? So we put a triangle. If we have a situation where there is a duplicate point, 10 milliliters, 1.5, 10 milliliters, 1.5, we put a circle around it. Otherwise, how else could you show that that exact point shows up twice? Okay? So you put a circle around it. And actually, there's another way to do it. If it shows up a third time, you put a little dash. If it shows up a fourth time, you put another dash. There's actually, like, this is all part of graphing, all right? So, but you put a little circle around it, and it shows that it has shown up twice. So if you have a duplicate point, for some reason, I don't know if you do, but if you do, all right? So next, so there's that. Questions so far? Okay, now your title of your graph is going to be whatever is on your independent variable with the units, your dependent variable, so this is going to be your dependent variable with the units versus your independent variable with the units. You could actually copy and paste the labels on your axes. Copy and paste, bloop. Copy and paste, bloop. Okay? Yes? It does. It is y versus x. That is correct. A science graph only shows you what the graph is showing you. That's all it's just titled. It does not have an opinion. It does not enhance it. It doesn't make it pretty. It just says this graph is showing you this versus this. That's all it's showing you. Yes?
Is there only one answer for both dependent and independent variables?
Yes, that is correct. Okay? The two reactants in this equation are baking soda and acetic acid. All right? There is also the product of the carbon dioxide, which we are measuring. But that's not a reactant. Okay, so that's the graph. Next, we're going to look at the data. I'll put that up so you can copy it, and let's take a look at the questions. So your first question is, which of the two reactants is limiting? So when you look at your graph, you should be able to determine which of the two reactants is limiting. So first, I'm going to say very clearly, carbon dioxide is not a limiting reactant in this reaction. I'm telling you this up front. Carbon dioxide is not a limiting reactant in this reaction. Can somebody tell you how you might know this right off the bat? How would you immediately know that carbon dioxide is not a limiting reactant in this reaction? Reagan. It's a product. It's not a reactant. It can't be limiting. It's a product. Thank you. All right, carbon dioxide is a product in this reaction. It is not a limiting reactant. All right, that was the number one answer I've been getting all day long, so I just thought I'd nip that in the bud. All right, not a limiting reactant. It's a product. Okay, so you're limited to, if you turn over to the front, the actual reactants. You have a choice of two. Okay, this is the baking soda. And this is the acetic acid. All right? The acetic acid, we know it's an acid. Does anybody know how we know that this is an acid? Yes, because it starts with H. Good job. It starts with H. And so we know that this is an acid. Anything that starts with H is an acid. What about water, Miss Paxton? In fact, water is an acid when it's up against a base because it will attach hydrogens to that hydroxide and make water. So question is, can it donate hydrogens? Yes, water has hydrogens to donate. It is acidic. All right, so if it has a hydrogen to donate, it is an acid. Baking soda is a base. All right, okay, so that's your choices, not water. Water is not listed in here, and neither is the carbon dioxide, not listed as a reactant. Next, you're going to choose one trial, any one that you want. Choose one. Pick the first one. That's great. I'm all about like picking the first one, but you can do whatever you want. Calculate the theoretical mass of the gas. What gas? The carbon dioxide that was expected to be produced. So you're going to need to, and this is like a change that I need to make on the lab, assume that the Alka-Seltzer is 100% baking soda, because it's not. And so that would make it very hard for you to calculate how much carbon dioxide you're making if baking soda is the reactant and you don't know how much there is. So assume that it is, and that way you know how many grams of the baking soda you have. Then the question is, wait, no, we didn't write that down. How do we know? So I'm going to remind you. The difference between these two columns is the mass of the tablet. And you know this because you took the mass of the tablet and you added it on to the mass of the liquids. Remember that? You had the mass of the liquids in the beaker, then you got the mass of the tablet. You added the two together as you dropped the tablet into the liquids, and that became the mass before the reaction. So in this case, 143.78 plus the tablet became the mass of everything before your reaction. Everybody remember doing that? Hopefully. Okay. All right. Next. Which reactant is the independent variable and the dependent variable? And then lastly, I want you to explain how your graph supports what you answered for number one. If you answered in number one that baking soda is the limiting reagent, I want you to tell me how your graph shows that. If you answered that acetic acid is the limiting, then I want you to tell me how your graph shows that. It's quite obvious, by the way, pretty obvious. So ask yourself the following question. After you're done with your graph, ask yourself, as I increase the amount of acid, what happens to my carbon dioxide? It blank, 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 blank. Okay, why does it do that? Okay, this is called interpreting a graph. It's grown-up stuff. Do it. It's good for you, all right? As I increase the acid, the carbon dioxide increases, continues to increase. Why? Because the baking soda and the acid continue to react together, producing more acid. My graph shows a continued uptick because they continue to react together. Okay then. Bravo. What happens as you increase, and why does that happen? That's what I want to know. Does it support your claim to number one? Okay? Got it? Okay. Questions on what you are responsible for today? All right, so I'm turning off the video.